Okay, we're going to go over section C in this video. First of all, we talk about some clarifications. So, in the very first part of this chapter, so the term pitch and elevator and fore and aft cyclic and also Nick are really pretty much the same thing. They're just the helicopter or the airplane pitching nose up and nose down. And the term collective pitch is not the same as pitch. Collective pitch refers to the blades, all the blades collectively increasing pitch and decreasing pitch. The term yaw and rudder are the same thing. That's essentially rotating or pointing your nose right or left. And the terms roll and aileron are the same thing, and that's rolling about the body of the aircraft. And the other thing, and this is typical with helicopters, that the left-hand stick on the transmitter does not control throttle like it does on an airplane. So this aircraft, before you take off, you use your stunt switch to stunt mode 2, and that means that your throttles are running in governor mode and they're always on. And then moving your left hand stick is just changing the collective pitch of the blades, which gives you up and down control in helicopter mode, and it's basically a way to control your speed in airplane mode. So then if you want to control your throttle when you're in this flight mode, then the way you do that is with your hold switch, which is your throttle hold switch, not to get confused with your gyro gain switch, which allows you to switch your gains of your gyros from a rate mode to a hold mode. So you go to a heading hold mode or a rate mode. And we fly the V-22 in heading hold mode all the time. So I'll just go over this controller quickly too. Hopefully you can see it, but we basically have an input side of the board, and this side plugs into your receiver. We also have a programming switch, so when your USB is connected to your PC without any power on the board, it can be totally hooked up but not powered up. Before you plug in your USB, you depress this button, and then I usually already have this one plugged in. I actually plug it into the computer at that time. And then when it's plugged in, you release the button, and these LED lights here will flash, and that'll indicate that you're ready to accept a program. So when you're ready to update your software on your controller, that's the way it's done. Then the other side of the board is essentially the top row. So the connectors go in horizontally, and it's all identified here in the markings. But the top row is essentially your two outer ones are your conversion servos, and then you use the middle sections, both top and bottom row, for to hook in your gyros, or use the middle section for your gyros, both the top, the middle, and the wire row. And then on each side of the nacelle, each side of this board, you have two wires on each side, and they're identified here, and they're the wires that go out to your wing, and they're identified with red, which are the power wire leads, and yellow, which are the signal wire leads. Now, even though these look like standard servo connectors, they're not. The power wire lead actually carries a motor and RPM signal into the board, which is the white one, and then black and red are the power. If you're running the nacelle mounted BEC off your speed control, then these wires actually are carrying power back to the ship, and if you're running the fuselage mounted BEC, then they're actually carrying power out to the nacelles. And the yellow wire is signals, and you end up with a throttle signal, a forward servo signal, and an aft servo signal. So these are all servo signals going down this board, and that's what the nacelle wiring board is for, is kind of to take these two plugs and turn them into standard servo plugs that you can plug in your servos and speed controls to on the in the nacelle. And these are broken up into a right and a left side. So that's essentially it. We have two more ports, which are the bottom two outboard ports, and one's auxiliary and one's gear. And the gear set's almost out. The gear program is out. Once you get the gear program in here, and then also you get your gear, retract gear set, upgrade set, you actually plug it into this gear port, and it'll actually, the controller will actually automatically run your gear up and down based on what it thinks you're doing. And then there's an aux port over here, and that's unused at this time. So that's basically the controller in a nutshell. So the transmitter is set up like any normal model helicopter transmitter, where you're running collective pitch on this stick and rudder on this stick, and then you're running elevator or fore and aft cyclic on this stick and roll or aileron on this stick. Now, you always want to have your throttle hold conveniently placed, so if you need to turn your throttles off quickly, it's very easy to do. And I use this switch right here on my transmitter, which is very typical. Some people use this one, but when I fly, I always have a finger on the back side of this switch ready to flip into throttle hold mode. Then you have your stunt switch, which is just like a model helicopter, switches into normal mode, stunt 1 or stunt 2 mode. And the way I set up the V22 is in normal mode. I actually have the throttles turned totally off. That way you can set up and wiggle your sticks and play around with it and check your conversion and everything, and never have to worry about the throttles coming on. In normal mode, the throttles are tied to this stick, so when you're at full back on the collective pitch, the motors are off, and then when you crack the throttle, the motors come on and go into governor mode once you get to about 25% stick position, and you can fly around with collective pitch as long as you keep your stick above the 25% position. And if you want to shut your throttles down and land, you can actually pull it back, and that'll shut the throttles down. Now that's fine and dandy as long as you keep the ship fairly low to the ground, and you kind of are not a real skilled pilot. You're not used to using your throttle hold, and you want to be able to chop the throttles this way. But when you start flying above head height, you need to have the stunt mode switch selected to stunt 2, and that basically runs your throttles at 100% no matter where your stick is, or in governor mode no matter where your stick is. And that way when you descend on rapid descents and you pull your stick all the way back, your throttles won't shut off. And when you need to turn your throttles off, you use this hold switch to turn your throttles off. Now, the gyros all have a gyro mode setting, and the gyros can be switched between rate mode and hold mode. Now, typically when the aircraft's sitting on the ground, just like a model airplane, if you're in hold mode, the servos can drift, so you usually leave this switch in rate mode, which I use this switch, and it's all the switches when you get ready to start are all the way back. But it's in this position for rate mode, and then after your throttle starts spinning up and you get up to about 50% RPM, 25% RPM, you can turn the gyros into hold mode, heading hold mode, and you can fly that way for the entire flight and not turn this back off till after you land. Now, on typical model helicopter setups, the volume of this switch controls the gain. That's not the case on ours. This just turns it from rate mode to heading hold mode, and the volume or the gain setting is actually done in the controller itself. That's because it has to control all three gain settings, and the controller has to do that. Now there's one other switch or lever that you need, and I use this slider on the side of the transmitter, and I run it with this pinky, and that's your conversion angle. So that's fully proportional, and you can fly around at any conversion angle you want with full control of the vehicle.